All right, ladies and gentlemen, today we're going to be looking at exponential regression, so you're going to need your calculators. All right, so please, if you don't have it, go and get your calculator. Okay, so we're going to be doing exponential regressions. It's a lot like when we did linear regressions, it's just a different button. So we're going to be putting things into list 1 and list 2, and then we're going to do a calculate. But sometimes when you look at it, you're like, okay, well, I don't even know which equation to use. They're not telling me. So it says in A, although a linear nor an exponential function would model this data perfectly, we want to know why it's better to use exponential. Well, you're looking at how is it changing. Because in a linear, you have to have a common increase or decrease. And in an exponential, you have to have a common ratio. So when I look at these, right, I'm going to compare. What am I going up by in each one, and then what am I going by as a ratio. So I'm going to list my population numbers. And 168. And in between these, here I'm going up by 12, here I'm going by 13, 17, 19, 21. So I don't have a common difference, right, when we were talking about them as our sequences. And that keeps, the difference keeps getting bigger, which lets me know it's probably going to be exponential anyway. When I want to see if an exponential one is good, I have to find the ratios. So I need 98 over 86, which is about 1.14. All right, and then I have to do 111 divided by 198, or I'm sorry, by 98, which is about 1.13. 128 over 111 is 1.15, and then 168 over 128 is 1.14. So here my ratios are fairly close, which means whereas my differences keep increasing. So this means that my exponential equation is going to be a better fit. All right, well, now I have to go through and I have to actually put it into my calculator. So we're going to be doing the stat edit in list 1, right, if you remember how to do that, hopefully. This is your list 1, this is list 2. However, we're doing it every year since 2005, which means you're going to be filling in 0, 1, 2, 3, 4, 5, and not 2005, 2006, and so on. So when you do that, you're going to put those in, and if you need to pause, go right ahead and do that. And then you're going to do a stat calculate, and this is 0, which is going to say xreg, exponential regression. And you're going to get, it's going to show you at the top this general form, and then it's going to give you A, B, and it's also going to give you an R, our correlation coefficient. So when I do that, right, we're going to have A is 85.598333763. B is 1.1439624, and R turned out to be 0.999. So a pretty good example. They want this, everything rounded to the nearest hundredth. So now I'm going to put it into my formula. P this time, because we're talking about population. 85.60, sorry I didn't leave myself enough room, times, I'm going to put it down here, 1.14 to the t, because they're talking about time and population. All right, so there's your exponential regression. Use the model to predict the population of deer in the year 2014. Well, 2014 means that t is 9. So again, I'm going to start with my formula, 85.60 times 1.14 to the t. I'm going to fill in 9. And knowing how to use your calculators and put things in parentheses is very important here, because you end up with 278.3667934. This is implied rounding, because you're talking about something that you can't have half of or parts of. So about 278 deer. All right, let's take a look at the next one. So now we're going to give you just 4 examples, and we want to know, is it going to be linear or is it going to be exponential, and then write the equation, which you can throw in your calculator, but we're also going to try to give you some hints here as well. And this line is extra. I don't know why that line's there. Okay, So type. So the first thing I'm going to look to see is there a common difference? And in this case, there is, which is 3. This 3 becomes your slope. First of all, this is linear because there's a common difference. This is your slope. Here is your y-intercept. So when I write my equation, y equals 3x plus 7. You can throw that into your calculator if you need to. All right, number 3, I do not have a common difference. So what I'm going to look for is, do I have a common ratio? So my ratio, in this case, is 3. That ratio is your b. Here is your y-intercept, which is your a, which I know is confusing because in the linear, it's going to be b is your y-intercept, here a is your y-intercept. It's a little weird, it's your starting amount. So by equation, y equals 2 times 3 to the x. And again, you can always put it in your calculator. All right, number 4. Right, when I look, this is certainly not a common difference. This is going to be our ratio, and we keep going down by half. Right, and that ratio then is going to be your b. Here's your y-intercept, your starting amount, that's your a. So this is exponential. Y equals 8 times 1/2 to the x. In this problem, this is certainly an exponential graph. And I'm going to pull some points off to help me see what I'm doing here. So x and y. So I have 0, 1. There's your y-intercept. I have 1, 2, 2, 4. So this time we're doubling. So there's your b. Here's your a. So y equals 1 times 2 to the x. And again, always put it in list 1, list 2 if you're not sure. All right, any questions? Bring them to class. Hopefully you're understanding what the heck we're doing today. All right, have a good one, guys.